today's class it's definitely not as computational as other ones may have been. Um, and it's pretty text heavy, but you really don't need to read a lot of text on here. So let's talk about JavaScript, right? And what it actually like means is and how you're likely to see it going forward in your career as a developer. So JavaScript for the most part, since its inception, which I think was in the late 90s, has pretty much primarily been a front end language, right? So when I say front end and back end, what does it mean? Well, if I was to say front end, that's the part that as a user, like the consumer, the end user sees, right? So when I think about like let's use Facebook as an example, right? The front end of Facebook is the actual app itself, right? With the blue wallpaper, with the buttons, with all the clicks and calendars and photos and everything. Like that's what the user sees, right? The back end of Facebook is the data warehouse, right? It's where like, hey, where do we store all of our data on all of our people, right? You see a photo on the front end, but it's not just always there, right? Like it's stored somewhere on the back end. And then when someone requests to say, hey, can I see my photo from 4 years ago? Facebook says, great, let me go look at my warehouse, find it for you, and then give it back to you. So the distinction between front end and back end sometimes can be a bit cloudy, but for the most part, you can think of it as in most web apps, let's say, for example, everything that you see in your browser, that's pretty much what we call the front end, right? Because your browser, in essence, is a really cool piece of technology, right? When you go to Facebook, what's actually happening behind the scenes is your browser is telling Facebook, hey, I have a request from this person saying they want this piece of data, right? When the browser sends it to the server, it also attaches some login info, some security info, and when Facebook on the back end gets it, it'll say, okay, great, this person is who they say they are, and they want this piece of information. Let me get it for you, and let me give it back to you. Okay, but what they give back usually it's not nice and template, right? It's usually HTML, it's CSS, and it's JavaScript because those are the computer languages that are most primarily used on the front end, right? So Facebook server is going to give you this big dump of HTML, CSS, and JavaScript, and what happens is your browser, which can be Chrome, Firefox, Safari, etc., they actually take all of this HTML, CSS, and JavaScript, and they actually render it for you in a nice way so that you see the nice layout that you get when you log onto any website. And so when we talk about front end, it's the part that the user sees, but really what the user sees is being compiled and it's being it's kind of being shown and rendered by the browser. Okay, so JavaScript primarily was a front end language for a long time. You only used it when you were trying to create things that you knew that was going to show up in a browser. However, about I guess at this point, almost close to 10 years ago, in like the late 2000s, basically something like Node or Node.js came on the scene. And what Node was it was basically it was I guess you call it an environment that allowed you to write JavaScript on the backend, right? So before Node, the backend was written in things like C or Python or Ruby, right? These were kind of other languages that were supposed to be used server side. Well, what Node did was Node says, hey, write JavaScript like you would write JavaScript anywhere else, and in Node we can run this code on the backend as if we can run JavaScript on the backend essentially. And so now for the first time, and this is why JavaScript is probably one of the most popular languages right now, is because you now have this universal language that you can run on both the front end and the back end, right? So you can use it to run your web server, and you can use it to render the UI that you want the user to end up seeing. Okay, if I gave Chrome, a piece of Python or some Ruby or some C, Chrome would just say, I have no idea what this is. I can't render it. It's meaningless to me. It's garbage, right? On the other hand, prior to Node, if you gave a backend server some JavaScript, they'll say, what do you want me to do with this? I don't know what this is, right? But now for the first time, if you're a JavaScript developer, you can write code that can be executed on the front end and the back end, which basically means now using one language, you can go across the entire stack, right? So when we say stack, it's usually a combination of both the front end and the back end. When people say I'm a back end developer versus I'm a front end developer, or I only work on this part of the stack, it means they have a specialty in either maybe working on the parts that people see or working on the server side or other parts of the stack, right? And so now for the first time, JavaScript was like, hey, I can do everything. As long as you know JavaScript, you can write code for both the front end and the back end. And because of this versatility, JavaScript essentially exploded in popularity over the past few years. I think in the latest Stack Overflow survey, it's like by far like the most popular programming language out there, at least according to their annual survey of developers, right? And part of the reason is for this very fact that if you know JavaScript, theoretically speaking, there's no part of a stack that you can't really touch, right? You can write it on either side. So now when we talk about, so moving back to the front end really quickly, so, assuming that it's a given that JavaScript can run on backend, in your front end, right? What actually renders your JavaScript? Earlier I mentioned it was Chrome, but really that kind of, Chrome is just an app, right? What behind the scenes of Chrome is actually rendering JavaScript. And so every browser has their own engine of what they use to render JavaScript. And what that also means is, quite fortunately and unfortunately, is that every engine renders JavaScript just a little bit differently, right? So in the second bullet point, Chrome has V8, which is a very, very powerful JavaScript engine, but Mozilla, Safari, and all the other browsers have their own, right? So the browser actually has this thing called an engine that can take JavaScript and render it according to a certain set of implementation or rules that define what JavaScript is. And these set of rules is what we call the ECMAScript spec. ECMA is a foundation of, I assume, people whose entire job, they're a nonprofit, so their entire job is to basically go through and say, hey, like, what do we want JavaScript to be? And more importantly, how do we want to improve on JavaScript in the future? So they publish the set of rules and guidelines that say, look, if you want to say you're in JavaScript, here are the things you have to do. Here are the rules you have to follow. And so when Chrome releases a new version of Chrome where they say, hey, we have a new engine for rendering JavaScript, it has to be ECMA compliant. And usually what that translates to is like, it has to be compliant with the latest version of the ECMA standard. Or if it's not the latest, you have to be very clear about which version of ECMA you're complying with. Yesterday, Sean talked about ES6 with you guys, right? And also he also would have mentioned ES7 as well. And so, it's very fine for you to say, hey, my engine only supports ES5 things, or it only supports ES6 syntax, but not ES7, right? But those are the kind of nuances and things that matter a lot when we talk about Chrome's, or sorry, we talk about browser and JavaScript engines. So when we run JavaScript in the browser, when you open up the developer tool, when we look at the console, right? For the most part, when you open it up, you'll see a bunch of HTML and CSS. Actually, probably mostly HTML nowadays. The CSS is probably hidden somewhere else. But you also see JavaScript, right? And normally speaking, the place where you run JavaScript in an HTML document is between the script tags. And basically, that just tells Chrome, hey, everything else real like it's normal HTML, like a CSS or whatever template language you want to use. But everything between these scripting tags, run it as JavaScript, right? And so here's where we start giving the engine some direction on, hey, you should read this part of the code as A and this part of the code as B. Okay, and the other thing is whenever a computer loads up, whenever your browser loads up this page, it will start executing the JavaScript right away, which could be a good or a bad thing depending on kind of what you want your page to what you want your page to do. Okay, so a lot of text here. Don't get too bogged down by it. This is just kind of good contextual knowledge, but this is just talking about kind of how the internet really works, or one way, a still oversimplified version of how the internet works, right? So essentially, you can imagine you with your computer, you have this kind of magic, man in the middle, and then you have like Facebook. Let's say like that's our example, right? It's you, the man in the middle, and Facebook, right? So when you go to Chrome and you type your URL bar, www.facebook.com, what your computer is really doing is you're telling the computer, hey, in the Chrome app, let's make this request for this data. This request then goes through the man in the middle, who's your DNS provider usually, who says, okay, he wants facebook.com, which is just a text, doesn't mean anything. But like someone reading out of a phone book, it will say, oh, but this address maps to this server, right? And so that's why when you look at a lot of server addresses, it's like 10.125.00, whatever it is. That's just a lookup to tell them, hey, where's which computer should I be redirecting this traffic to, right? Obviously, if you're small, you have one site. You say, hey, my server's at this address. If you're Facebook, due to both geography and volume, you might have like 1,000 addresses, right? You might say, I have 1,000 servers all over the world, so that if someone's logging in from New York, they don't need to wait, like 3 seconds because my server is located, in like well, I was gonna say like China, but that's not allowed. So like it's not okay. It's somewhere else, really far away, where it's like just not convenient, right? So it's also good for a lot of companies to distribute their servers in different places, so that one, people get their data faster, but also two is that if one server goes down, you have another 999 servers to back you up, as opposed to having one thing run all the traffic. And then the man in the middle will say, oh yeah, I'll send this traffic over to this Facebook server. This Facebook server will say, hey, let me get the info for you. I'll send it back to the man in the middle, who will then pass it back to my browser, and voila, that's how you get your data. There's the intermediary steps are super complicated, and even I don't know like all of them. But the only other one to really be aware of is in the second bullet in the World Wide Web. Oh, sorry, there's two bullets you should be aware of. One is under World Wide Web. Just understand that there's like a protocol or there's a set of rules that every player in this process follows, right? When your browser submits a request, it has to be formatted a certain way, right? There needs to be certain behavior, like how long do I wait for a response? When your DNS, where the man in the middle gets the request, they have rules on how they read the data and how they forward the requests along. And then as a server, they also have a protocol on what kind of data am I receiving, and what kind of data do I give back, right? To the different what kind of data can I give back as a response, so that someone else knows what to expect. So there's a bunch of rules and protocols in place, and that's why most of the times when you go to a site, it says HTTP or HTTPS to be secure. But those basically, HTTP is a protocol, and it's probably by far the most common one on the web right now. The other thing to know is this last bullet down here is sandboxing, right? So when you run JavaScript on a browser, for security reasons and for a lot of other reasons, right, you really want to limit kind of where that JavaScript has access to, right? Much like how when we talk about functions and scopes, you want to limit what that JavaScript can do, right? When you go to Facebook.com, you don't want Facebook to say, oh great, I'm on your computer now. I'm gonna go through like your My Documents, your downloads, and everything else on your computer, because that'd be terrifying, right? Arguably, Facebook can know a lot about you too from other means, but for the most part, is just because you're writing JavaScript in a browser, you're running JavaScript in a browser, you don't want that to be able to hijack your entire computer. And so, for the most part, most browsers do a very good job of restricting the parts that the JavaScript has access to. Usually, it's just a page or some very limited parts of the page even, or of the browser. When you go to some sites, for example, you might get like a pop-up that says like, allow this site to access your microphone or your camera, or accept something else, right? These are all different ways for the site to say, hey, I need access to other parts of you, but by default, I know the browser's not gonna let me do it, so I need to request you and get your explicit permission before I do this. So even when you're developing, as a consumer, you feel pretty safe because for the most part, the browsers do a pretty good job of restricting this. And if you're a developer, always be aware of what you do and don't have access to. Although this is also just obviously a huge point of hacking and kind of nefarious use cases, right, where people can jump out of the browser and get access to a computer, which is extremely dangerous. The DOM. The DOM is basically what we think about when we think about like when Facebook gives you back a pile of CSS, HTML, and JavaScript to render. What does it look like? Well, it's actually like a model, right? Like on the right here, you see these tags. You see an H1 tag. You see a script tag. These are all theoretically objects on the page, and really what we're doing is, in this case, we're just rendering it, when we first load the page up. But then if we want to say, hey, we want to give someone a drag and drop feature, well, now we're just changing these objects around. And so the DOM is basically a way to think about every single thing that you see on your page as its own object, right? And really, the web page is just a collection of these objects, and Chrome is responsible for rendering them, ordering them around, and possibly moving them around down the road as well. So I can go back and do a demo of what the DOM looks like and what we can do with it later on, but that's just kind of how we think about the DOM. So in terms of moving around things in the DOM, there's quite a few ways to do it. You might have heard of jQuery, which is one of the more common ones, although I think it's slowly, there's people playing around with other ways to to do it. And so something that you could do with jQuery is say, hey, give me all title divs on this page and make them twice as big, right? Or find me all paragraphs or find me all text and delete them from this page, right? So jQuery basically allows you to manipulate the DOM in a much bigger scale way. Previous to jQuery, because every browser also implemented things a bit differently, the way that you say, hey, if I want to 2x the size of all my title fonts, I would need to go in and manually change each individual title div, right? And then I would do it differently in Chrome and Safari and Mozilla and everything else. But with jQuery, it was just a really good way to just do things, to change around the DOM in a much more scalable way. And then even more recently, we have these things called front-end frameworks. Google has one called Angular. Facebook has one called React. And they're basically other ways of using JavaScript to render what you see on the page and in the DOM. So notice how even though these frameworks are different, like names and different things, these are all just fundamental JavaScript. Like they're all written in JavaScript. So sometimes you might see it called Angular JS or React JS, because once again, these are all JavaScript based frameworks, and they're just other ways for you to create a website on the front end. And that's pretty much it, right? Like I said, like not a lot of like hardcore text today. But if, for example, if I wanted to go to any site, let's see what depressing news we have today. Okay, cool. So, okay, cool. All right, cool. So here, let me just go here. Let me just make this up. Okay. So here's when I open the console, right? This is what you see, and this is something I think all of you have been. Oh yeah, sure. Thank you. I guess this white is really hard to see. Okay, so basically here, if you just open up the console, if you don't know how to do it, you can literally just right-click anywhere on the page and go to Inspect Page, and it'll open the console for you, right? The console, basically, you can think of it as like a more developer-friendly toolbar for your Chrome browser, right? So in this console, you have a bunch of things. In my case, I have AdBlock, which is like its own app. I have audits, security stuff. I can see some performance metrics as well. I can see my incoming and outgoing requests. Console, which I think a lot of you guys should be familiar with. Here's where I can actually just write JavaScript. I can do console.log, like hi, right? Like I can just execute JavaScript here, like I would in any other IDE, like REPL or anything else. But what I want to show you is elements. And so elements is basically this DOM, right? So this is a document object model, right? Every single thing on this page is an object, right? So you can't really quite see it here, but there's this body container here that I'm hiding over. If we open it up, we click on this arrow, you'll see it's broken into several parts. And actually, it's broken into a lot of parts, right? And each part, when I hover over it, it will highlight on the page which parts I'm looking at. So for example, if I want to take a look at this section 1 here, and I break it down more and more, you'll see like kind of how each individual section on the page is grouped, right? So each of these is an object, and if I choose to delete any of these objects, it deletes it from the page directly, right? Notice how when I do this, actually I'll just do it up here. So let's just say, like I hover on this text, and rather than changing this, I say, hi full stack. I'll misspell this probably, but yeah. Like, notice how it changes on the page directly, right? And the only reason why this works is because, once again, remember how in the process we were describing earlier, what happens is this is not live from the server, right? The server says, hey, David, here's all the documents you need to render this page. Take it, right? So, when we talk about, pass by reference or pass by value, you can think of this as like a pass by value, right? They're giving me my own copy of the CNN homepage to render. So I can do whatever I want to it, right? I can go through it. I can change the text on it. I can say, hey, you know what? Like, I really don't like, this photo. I'll click on it. This is where the image is. And if I delete it, then it deletes it from the page, right? Obviously, when I do this, this doesn't affect CNN at all, right? Because this is my own copy of a bunch of JavaScript and HTML and CSS that CNN gave back to me. Okay, so this is the super important part of all this, is that you can think of Chrome basically as like another template or another text editor for you that shows you all these things. So you can change whatever you want on here, and it won't affect anyone else. It won't affect anything on the server. Right? It's almost like once the server gives it back to you, you sever all connections to the server, and you sever all connections with the server, and now you have this kind of independent copy of all of these texts for yourself. So we can actually change all of these, right? The other thing you can do if you want is like, I think all these are gonna be links, right? So if I click on this, I go here, and then I go here. I hover over this, it'll say, oh look, here's this link, right, to the site. If you click on this button, this is where it would go. And actually, I can go on to cnn.com and do this, and it should work, right? Because these are all valid email addresses as well. Or sorry, all valid web addresses as well. So one of the things that you can do as you kind of get more and more experience with that, like when your website's down, like figure out why it's down. A few weeks ago, I think some of you guys here were aware, I had a flight canceled on me last minute, right, by an airline. And so when I tried to go online to rebook, they basically removed like the rebook button, right, which is like, oh darn, like now I can't rebook anymore. But when I went to the DOM just to kind of see what they were doing behind the scenes, it was like super simple, right? What they were doing was they had this div that was a button that had a valid URL attached to it, and they just said, hide it, right? So which is super like, and the reason why I say it's kind of dumb is like if I go to, for example, if I say I go back to this thing, imagine if this full stack button was like something, right? And I can say, hey, I can say display, I can just say it's hide one. No, I think it's none. If I do none, oh look, it's gone, right? And so if I was a user and I see it, I say, oh wow, there's no button here to rebook the flight. But if I just changed it normally, it came back, right? And I can actually click on the button and follow the link through because the URL behind it was still valid. And so this is just for you guys to understand that like there's like a lot of like when you see a website, when you see any piece of tech, right? To the best of your ability, always try to understand what's going on behind the scenes, because most of the time it's both complicated but also not complicated, right? Like if you know that like, hey, if I disconnected from the Wi-Fi right now, this page would not go away, right? It would still be here. And the reason for that is because I have my own copy of the page. And that in itself tells you one really important thing, which is that, hey, look, CNN actually gave me everything I need to render their page by myself. Another thing that I sometimes do is that if I'm on a site and I see, oh wow, this site is designed very beautifully, right? Or that this one color or this one feature I really like. How do I copy it? I just go to the console, I click on it, and let's say I really like this CNN red. Although I think this is a picture, so it might be hard to copy. Yeah, I can't copy it. But if I say, hey, I really like I don't know, this is not right. Oh, I really like this black as a color, right? I think it's somewhere here, or is everything on this page a logo? Maybe not. But if I click through this, I see, okay, the color here, it's 262626, which I think is black, right? But if there's like a different color, if I change this to maybe like 3, 4, or, oh, didn't that do it? Or is it inheriting from somewhere else? This is also like where nesting gets in play because it's super like, okay, so that wasn't it. But all right, let me just go to the page here and I'll say background here, the color's white. If I make this into a 2, it now turns into this like kind of like yellowish. Can you guys see it? No, maybe not. All right, let me change something. I think the earlier do it. This is like the blue. No. Okay, let's just go like ambiguously like colors. There you go. Now the color's changed, right? Like if I'm on this page and I'm like, wow, I really like this. I really like this color. After I get my eyes checked, I'm gonna go to this page and I say, oh look, they're using it, and this is the hex code for it, right? This is the color that will render on any other site. So I can just take it myself, copy it over, and say, hey, you know what? I want to, assuming this was like black, right? I can always change it back and copy it myself, right? So it's also very easy for you to figure out, for you to kind of work out what other people are doing, right? Because at the end of the day, like software, more than anything else, it's a very open community. You've heard the word open source, and to the best of my knowledge, open source doesn't really happen like in almost any other industry, and definitely not to the extent that happens in software, right? Like you have entire projects, entire company to say, here's all of our code, right? Like we're gonna trust the fact that you don't have to scale to copy it, but if you want to know how it works, here's what it is, right? Like this is not hidden from you. They have everything. If you want, you can manually recreate CNN's website because everything they have is on this page. Okay, cool. So that was pretty much it. Just talk about what JavaScript is, how you would see it on your day-to-day side, how it looks in the browser, and kind of trying to demystify a lot of the, I guess, more like obscure parts, or maybe more the opaque parts about when you see code, and especially when you see JavaScript. Any questions? Yes.
If you can briefly, do you know if you go onto a site where there's something that's semi-live, like it's changing on the site without you refreshing? Do you know how that would work?
Yeah, so that's actually a very challenging problem to solve, and something called it depends on how you want to do it, right? So there's something called basically it's called polling, which is basically like imagine like so normally if I was to request a page, right, the server says here's your page, like go away, right? Like that's it. That you have your page, and you're separate from the server. In some cases, what you can do is you can actually establish an open channel with the server, where you keep asking it, hey, is there anything new? Hey, is there anything new? Hey, is there anything new? Right? And you could do this, once every like 5 times a second or whatever interval you want. But by doing that, by polling, essentially by asking the survey, the server, do you have anything new? If the server says no, then you just ask again a few seconds later, right? If the server says yes, then now the server knows who to respond to, and it'll give you back the newest and updated data. That's one way of doing it. There's a few other ways of doing it to kind of maintain that real-time updated feel of things. But for the most part, like on most websites for security and for practical reasons, most connections with the server kind of go away after 30 seconds. It expires, and so that's why sometimes if you're loading a page and it's really heavy and takes a long time to load, you might get that like gray dinosaur screen or whatever it is from Chrome, right? Saying, hey, like the page can load, and that's not because the server said no. It's because Chrome said, look, you've been asking this guy for data for 30 seconds. It has not here yet. I'm gonna assume that this connection's dead. Like I'm just gonna cut it off. Okay, so because there's this inherent time cap on a lot of website server requests, maintaining that polling is actually very hard, and so sometimes you may need to have like a function that keeps creating new connections every couple seconds. But polling is probably the most common way to do it. There are a few more technical ones, but actually like no one's really designed like a perfect way to do this where you only get data when you need it, right? You might ask, well, why can't the server just say, hey, the server got new data? It'll just tell you that it got new data, right? But the problem with that is like the server one doesn't actually know who has their latest documents, right? Like if I go to cn.com and I'm on their webpage and they have an update and they send it back to me, like that's great. If I'm on cn.com and then I look at it and then I close my browser, I go to another page, I don't want CN to keep sending me stuff, right? So from the server side, you also have this sense of anonymity where you don't actually know who's on your site or who's connected to your server or who's currently accepting requests. And so it's kind of this double blind scenario where both sides would like it ideally if there was an open channel of communication, but for safety and practical reasons, it's hard to maintain that. Cool. Any other questions about JavaScript or the browser? Yeah.
This is a little bit of a tangent, but like if you keep asking the server to, I guess, a separate request, doesn't that create like a DDoS type of thing?
Yeah. Basically, a DDoS is like what like a denial of something of service attack,
Yeah.
which basically says like so if you have a server, imagine a server, right? Someone says, hey, can you give me the site? You say, great, here's your info, right? Someone else says, give me the site. Great, here's your info. But if like a million people come to you at once and say, hey, give me your site, the server will just queue them up, but basically the server will get overloaded with so many requests that will basically just like explode or time out or say, hey, look, something happened, I'm overloaded, I don't have enough memory, I don't have enough RAM, I don't have enough processing power, and the server will go down. Okay, and so what a DDoS attack is saying it's like once you figure out the address of a certain company's server and you want to take them down, you just hit that company with as many requests as possible at the same time to overload it, right? If you're a big company, usually it's not a big concern. Or if you're a big enough company, small scale DDoS attacks aren't really hurtful to you because, like I said, you have millions of servers probably spread out across the entire world, right? If one server goes down, you just go to another server. But if you only have one server or you have a few select servers, or if one server is somehow very critical and serving up very important information that other servers don't have, and someone discovers it, then they can attack it very aggressively, right? So some of the sites, if you go on now, when you go to the site, they'll actually have this like loading screen for about 2 or 3 seconds. And the reason why they have that is because they want to prevent DDoS attacks, right? So if they get too many requests from you at once, those kill it at that point, rather than having your request actually make it to the server. But yeah, hitting a server with multiple simultaneous requests is one way of taking out a server if you wanted to. Any other questions? Tangents? Yes.
Also kind of a tangent. Is Spotify known to be like really not secured?
In what way?
Like the premium accounts? Because I went on Twitter because my fiance's premium Spotify was hacked by someone in Poland,
Okay.
and they kept like erasing his playlists and making their own like the Polish like top 100.
Okay.
So I went on Spotify. I mean on Twitter just to check.
Yeah.
And it is a thing, and I don't know. Is
Maybe.
It really
I mean,
easy to,
Spotify is a pretty relatively young company, honestly, and I would say that like, you know, it's kind of like this like weird conundrum where like if you're really old and big, like you have a lot of security issues because a lot of your processes and computers and software are out of date. And if you're really young and scrappy, you just don't have time to worry about security. So those are kind of like the barbell effect of who's most likely to get attacked. But I mean, like web security is always going to be a growing concern. And it's really funny that like someone can say like a lot of security companies are saying like we'll make you secure, right? But it's kind of like a cat and mouse game, like where both sides are just kind of upping the arsenal, right? So like I personally don't know if Spotify is any less or any more or less secure than any other site out there. But I know banking sites which are they invest so much on security, right? They get hacked all the time, right? Like Target got hacked, right? A bunch of people's credit card info got leaked. Like so, it's never like no one's really ever perfectly secure. And it's kind of like one of the things about computers. Like once it goes like in the cloud or on a server somewhere, it's pretty much fair game for anyone who can try to access it. In fact, like the last big DDoS attack that took down like some of the major sites around was because I think what happened was people was able to hack into like IoT devices. So not just like the Alexas, but like the Nest thermostats, the Ring doorbells, like all these like random small gadgets. Like they're all computers, right? They all make requests. They're connected to your phone or Wi-Fi because they can make requests, right? And so they actually hacked a lot of those, which have zero security value, really. Like people like if you're a thermostat maker, you're not thinking about how to make your thermostat like super secure, right? And so someone's able to hack into a lot of IoT devices and have those things make requests to a single server. And so like yeah, like I guess all this is to say that like it's hard to ever say you're secure, and people who they've probably gotten hacked because some people see it as a challenge, but no site's really any more secure than others unless assuming they prioritize security, right? So like Yahoo, like their big leak like a few months ago, like that was more of an egregious violation, mostly because they knew about the hack several months before they announced it. But for the most part, I would say like everyone's equally unsafe. And it doesn't make you feel any better, but it's just kind of the truth. Yes.
You talked about React, and I
And-
know that Facebook has a million things like that, like Yarn and all these other ones. Is there like
Oh, that's sorry, keep talking.
no?
I know
just, like,
what Yarn
wonder,
is.
I was at their developers conference in March, and they were going over all of them. Like, what's the best way to like know about all these things and know to use them?
Huh, yeah, package manager for. Oh, okay. Yeah, so this is. Okay, yeah. So Yarn, okay, yeah. So I guess the short of it is that like rather than trying to keep updated on every single thing,
Yeah.
like pick the tools that you actually want to use and just like stay on top of those for the most part. Like like just 2 weeks ago, React or Facebook rewrote the underlying engine for React. It was like something called Fiber, I think, or Fiverr, whatever. But there's new innovations on all of these software and platforms and libraries all the time. And if you try to keep track of all of them, your head's just going to explode, essentially, right? So usually I think what people do is they say, okay, if I want to, for example, specialize on the front end, right? What are the things I need? Well, I can specialize in a front end framework, and I'll pick, Angular, React, or Flat, or something else, right? Like whatever I want. And then I'll say, in this case, Yarn is a package manager for JavaScript, which basically says, how do you manage your third-party libraries, right? and say, you know what, hey, if I'm okay with Node's package manager, I'll use that. If I want to use Yarn, then I'll know that, right? But usually people try to like have a core set of libraries, we call them, that you're familiar with, and you get really good at those, and those become your foundation. And over time, you can pick up more and more different libraries as they come out. But you can't keep track of everything. Like things go in and out of vogue so fast. Like when I started at Full Stack a while ago, like they've been teaching Angular as a default front end library, and then a few months later they're like, oh wait, like React is clearly like the more popular framework now. We should teach that instead because that's what employers are now looking for, right? And then in terms of kind of keeping track like of React or of Angular, I would say for the most part, like the companies that make them try to be very stable with them as much as possible because they realize that if you keep changing things up, it's very chaotic for users to keep track of, right? So to the best of their abilities, they try to make these changes as infrequently as possible or as small as possible. Um, but yeah, focus on the ones that you like and are comfortable using first, rather than trying to follow the fads. There's too many. Oh look, okay, yeah. So this is basically like a front end for the npm package manager library, or sorry, another way to manage things in npm. And like it's really cool, right? Because like you've heard of have you guys heard of Redux, which is like people usually say React Redux, right? It's like kind of they say it as one thing, but it's actually two different things, right? Facebook published React, which is a way to render components. Redux is a way to keep track of what data do I know so far on the page, right? The really cool thing about Redux is, well, there's a few cool things about it, right? One is that it's actually super simple, and two is that it actually wasn't written by Facebook, even though they go so hand in hand. It was written by some good developer who saw React and said, "Oh, it's clearly missing this part of it. I'll just write it myself. I'll make its own Git repo. I'll publish it as its own package, and then like people can start using it." And that's what people did. People started using Redux more and more. And then I think eventually Facebook hired the guy because it was like, come on, like clearly this guy knows your tech stack probably better than some of your own team does. But like it's really cool because like anybody can build anything they want off of existing technology, and because of that, anyone can kind of write their own library. And that's another reason to not follow the too many fads, because if anyone can do it, it just gets too chaotic, right? Like if I even want to do like if I search like Git React repo, like if you want, I think React actually this, and for React this is the case. Like this is React. Like this is we hear about React, we know it's by Facebook, but like here's all the code you would ever need to recreate React yourself if you wanted to, right? If you want to take the time to know how React works line by line, here's the code. It's Googleable. It's on Facebook's GitHub. It's public, right? So if you want to build something on top of React, this is where you start. If you want to see what updates have been made, I mean, it looks like the newest update came out yesterday for something or other, right? And obviously, Facebook React, they keep very tight ranks on who can't change it. But like I said, software is very democratic in the sense that like they don't really try to keep too many things in the black box, right? Like here's everything you need to see how React works. So yeah, if you want to write your own libraries, go ahead. And actually, for a lot of like much more senior level developers, like if a company's hiring to be like someone at an architect level or someone very 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 structural, where they want to see, hey, can you build really large projects? A lot of those candidates do have like repos or projects on GitHub with thousands, if not hundreds of thousands of forks or downloads, right? And they say, I know how to build large-scale manageable projects. Like look at my Git repo, like I've built this before. And so it's also a really good resume builder too, to build things that you feel like other people want to use. Issues, complaints. 4,000 down, 600 to go. So if anyone wants to raise an issue with React, like let's take a look at this one. It's like this guy basically says, hey, I found a bug. Okay, yeah, it basically says like when you click on a certain HTML element, the on page handler doesn't work. Here's a problem. Here's how I duplicated it. Here's how here's are the steps for recreation, and here's what I'm using. Right? Like this is like so cool, right? Like in no other industry can you can't really go to like Ford like, hey, can I see the blueprint for all of your cars? And by the way, I think you should make this car part this way. Like anyone can say that. Like anyone can make a request on Facebook. Worst case is Facebook says like you're dumb, like close the ticket, and they'll like ignore you. But like you can't go to the Ford factory like, hey, I think you guys should remanufacture your cars differently. Right. So this is like really awesome. Like this is why I think software development is really cool because it is democratized in a way that really no other industry is. All right, cool. Yes, back.
Like the different versions of JavaScript, right? Like you talked about
Yep.
Angular and React. I mean, how different are they from each other and from what we're learning right now?
Yeah, I wouldn't think they're actually built off the same JavaScript. So think of JavaScript as like English, right? And like Angular could be like a certain layout of like expository writing versus freestyle writing versus another form of writing. It's like in all these library cases, the underlying language is JavaScript, so they're just using it differently. In the case of React and Angular, I would actually say there's a large amount of difference in how you think about like the components that you're treating. So they can be very very different. But I would say like once you get to a certain level, like once you get really familiar with JavaScript, like the real fun of understanding how these things work is like really understanding how they think about like the overall like the best example that I can think of is when you think about like language, right? Like how like in English you have this very much like for example in a lot of European languages, right? Like objects have like have genders, right? It's like feminine or female or male or neutral or whatever it is. And in English you don't have that, right? So it's like a very like unique construct of way of thinking about how language works, or how in some like Arabic languages, I think the way that the nouns or the verbs are placed in orders are different, and so it makes you think about like a sentence in a completely different manner, right? And so that's what Angular and React could be thought of as well, in that like React says, hey, look, nothing on this page should ever change, and if anything does change, I'm just going to rerender the entire page, right? Like if you type in a letter on a React page, it will rerender the entire page for you based on what you typed, right? Angular says, no, let's just keep that text box as is, and if you type something, I'll just add one more letter to that box, right? So they're like very like fundamentally different ways of thinking about how to solve a problem, but the language behind it is the same. And so you might find libraries are very, very similar. You might find languages that try to do something very, very different. It really depends, but like as long as you know JavaScript, you should be able to work through it and figure out kind of what's going on in any case. Cool. Anything else? Free for all. Just ask random computer questions.
Well, I have one.
Yeah.
Random question. I was talking to a friend of mine who works in computer a couple weeks ago, and he said there's something called Ionic these days.
Yeah, Ionic. Yeah, Ionic is it's another framework. I think it's for Mo. I think it uses JavaScript to make iOS apps. I believe. Let me double check
He was
that.
saying that you can now like create apps entirely on JavaScript and run it through this Ionic.
I think Ionic basically just translates JavaScript into iOS. So if you want to build like an app for the iPhone, you have to use it in Objective C or Swift, which is like the newer, very JavaScript-like language that Apple came out with at this point, maybe like 3 years ago. It feels like very recently. So if you want to build something on an iOS platform, you have to use those languages. However, things like Ionic and a few other similar frameworks basically allow you to write JavaScript that essentially in some ways gets transpiled into I think Objective C behind the scenes that can then be translated into a mobile app. So if you want to publish an app but you don't know the iOS languages and you don't want to learn it, you can write it in JavaScript and something will translate it for you. So that's what Ionic is. Yeah. And like almost everything like Ionic, I'm pretty sure is open source too. The other reason why companies really like to open source their stuff is because you get really good feedback, right? Like rather than having a small individual team try to QA everything, like open to the world, and people like pointing out when others are wrong, and so there's this like kind of like There are a lot of people who say, I'm just going to read through your documentation and find all the errors and tell you about them because, I don't know, reasons. And then they also make really good suggestions. And in some cases, like Redux, they'll write the code for you on how to make something better. And then if you like it, you can just incorporate it as part of your own stack. So yeah. Are they charging for Ionic now? It was free a while back. I don't know. I guess they gotta make money some way, right? I guess it's charging for enterprise. But yeah, JavaScript super popular. And because it's so popular, people translate JavaScript into other languages all the time. All right, cool. Let's move on to the workshop. Today, like I said, there's no new concepts in terms of programming concepts. So it's mostly review. So I'll open the workshops and then feel free to take a break and then get started when you come back.